Good morning, on and all present here. I'm Nandhini, working as an assistant professor in SNS College of Engineering in the Department of Computer Science and Technology. Today, we are going to see a topic called Motivation Address Capabilities of IPv6 Protocol Overview. What is an IPv6 motivations? The challenges that we face today is in supporting emerging demands for address space cardinally, high density mobility, multimedia, and strong services. IPv6 offers potential achieving scalable reachability, end-to-end interworking, quality of services, and commercial grade robustness that is needed for contemporary and emerging web services and data services with the help of mobile video and Internet of Things applications. IPv6 was initially developed in the year 1990s, which is used for system addressing based on anticipated internet growth and compressing mobile phone deployment, smart homes, applications, and billions of users in developing countries. This IPv4 addressing and issues. These consist of challenges of IPv6 addresses. In IPv version, size of the address space is mentioned as IPv4 and IPv6. IPv4 consists of 32-bit and IPv6 consists of 128-bit. With an examples of an has been given. It consists of unicast with the same function as in IPv4 and broadcast eliminated and replaced by multicast by expanding functions. Anycast totally a new approach sent to any one member of this specific group. There are a number of specific IPv6 addresses. This IPv6 address capabilities consist of 16 byte each, separated by the colon, which is also known as a character. Each 16 byte group is represented by 4 hexadecimal digit, that is each digit has a value between 0 to 15. Example 3223. An abbreviate format extension to design IPv6 addresses when all ends are 0. Example is been shown with the here 3223 colon 0BA0 colon 0000 colon 0000 colon is represented in this form. Next one is a special IPv6 address as follows. This auto return or loop back virtual addresses. This address is specified in IPv4 as the 127.0.01 addresses is represented as colon of 1. Not specific addresses. This address is not allocated to any node since it is used to indicate absence of addresses. In IPv6 and IPv4 dynamic or automatic tunnel addresses, these addresses are designed as IPv4 compatible of IPv6 address and allows the sending of IPv4 traffic over IPv4 network in a transparent manner. They are represented as an example in this format. These IPv4 and 6 are automatic representations. These IPv4 overview. There is an version, traffic classes, flow label, payload length, next header, hoop limit, source address, destination address, and extension addresses. These are all being used here. Packet formats are being used here. Next one is a base header, which consists of flow level label 20 bits defined from traffic handled and identified. 16 bytes payload in octets includes the extension header as well as the upper layer protocol. Next header 8 bits identifies the header, immediately follows the IPv6 header and a hop limit 8 bits identifies the number intermediate nodes on which the packet is allowed to travel before being discharged by the router. Next one is IPv6 overview, which consists of a security header that provides authentication and integration, encapsulating security payload, a security header that provides authentication and encryption. Next one is a fragmentation header. The fragmentation header is similar to the fragmentation option in IPv4. In this auto configuration, a new character of IPv6 protocol that facilitates a network managing and system setup task by user. It also called as plug and play. SLACZ term also uses for auto configuration. It expands the stateless demand of this process. In this IPv6 address formatting, 128-bit addresses, 64-bit addresses, and these defines an interface identifier. Higher 64-bit of the address is identified with the help of path or the prefix of network router in one of the link to which such interfaces is connected. The IPv6 address is formatted by combining the prefix with the interface identifier. It is possible for a host or a device to have IPv6 and IPv4 addresses simultaneously. It is also possible to transmit IPv6 traffic cover over IPv4 network tunneling methods. This approaches consist of wrapping the IPv6 traffic as IPv4 pay layout. So this overall overview of IPv6 has been explained here. Thank you so much for the video. Thank you so much for the video.